Let's look at two more assumptions. The author lists 4 critical assumptions he makes, and this is on the role of values. Assumptions about the role of values. Researchers involved in traditional science should primarily be concerned with the pursuit of knowledge and be as neutral as they possibly can in relation to values. There are lots of arguments made that science happens in a value framework and that affects the interpretation of empirical experiences or data and so on, or experimental outcomes. Although it is impossible to be objective and value neutral according to the epistemological assumptions above, we are not destined to only produce subjective accounts from which only political processes can distinguish the successes from the failures. For researchers to be as value neutral as they possibly can, it's essential to strive to be reflexive and to identify and get beyond prejudices and biases. Value neutrality is, in other words, an unreachable vision or ideal that researchers involved in the pursuit of knowledge must chase with great strength and stamina to be able to get as close as possible to the realities under study. The vision of value neutrality is, however, only vital in the pursuit of knowledge itself. It is not required to attempt to abandon values when it comes to what is perceived to be significant in selecting the areas of inquiry, nor are normative values prohibited from being involved in the process of utilizing scientific results to solve real-world problems. This may be done with scientific rigor and is the focus of design science, which I will present in more detail in chapter 8, so we'll come back to that. To read a little bit more, traditional science is well equipped to deal with how things are in the world and so on. So we will look here at what David Hume pointed out in terms of Hume advocating a complete division between what is and what ought to be, which is rather theatrically illustrated by the principle's common epithet, Hume's guillotine. However, it's important to note that that also values do not have. I am feeling a little groggy somehow. Sorry about that. However, it is important to note that also values do have grounding in reality and in the myriad of experience of human interaction, but I do not believe that it's undermining Hume's argument. So this is the great Scottish Enlightenment philosopher David Hume. Statements about how things ought to be cannot be empirically inferred from statements about how things are, as these two are entirely different from each other. For instance, the prescriptive statement the authorities should lower the speed limit on all 90 km per hour roads to 70 km per hour cannot be empirically inferred from the descriptive statement the number of fatalities per car in the accidents is 30% lower on the 70 km per hour roads compared to 90 km per hour roads. However, the descriptive statements should be allowed to inform prescriptive statements, but the statement itself will always be essentially inferred from value preference, i.e., if we value the potentially saved human lives higher than the costs and inconvenience of longer travel times. Hence, it is vital to be transparent in what values prescriptive statements rest on. So this is a bit complicated here, but we have to understand it. So if you focus on the importance of road safety in terms of reduced number of mortalities, then obviously data would suggest you should go from 90 km per hour to 70 km per hour. But if you add other factors like travel time and cost involved, let's say, in going slower, then the statement of the problem of values becomes quite different. So there is a combination of values and so on that is implicitly assumed when you say let's save human lives, right? Assumptions about complexity then. As I show in the first part of this book, sustainability science is concerned with the pursuit of knowledge of a wide range of phenomena as well as with solving as equally wide range of real-world problems. However, how these problems and phenomena should be approached has been debated for decades, mainly in the form of more or less fierce advocacy for two seemingly disparate standpoints, reductionism and holism. Reductionism is where, as we said before, you take the landscape in front of you and you simplify it based on, in terms of what is needed to be included to model it in some ways, based on whether you are a real estate person or a farmer or a hunter. When looking at, so that's holism, means you include everything that is there in reality. But let's get complicated. When looking at this conflict, much appears to depend on the definition of reductionism. If reductionism entails the standpoint that a system is nothing but the sum of its parts, it is irreconcilable with holism. However, if reductionism instead entails the idea that to address the whole requires a composition of it in its parts and examining relations between these parts, they need not be fundamentally conflicting. So you can take a problem and represent it in pieces. It's not like a clock that you have to assemble completely to make it work. That if the landscape has vegetation, water, hills, animals, then can you look at parts of it and analyze it or model it and then combine them to create the whole again. So you have there is a reductionism involved in looking at some parts of it without forgetting that that's not the complete part. Reductionist approaches attempt to isolate fundamental parts of a specific phenomenon or problem and to examine relations between some of these parts while assuming others to be constant. Holistic approaches, on the other hand, advocate the view that more complex phenomenon or problems as wholes cannot be explained, understood, or solved by studying parts in isolation. So in natural sciences, this is very common. If we want to understand the human natural system or human environment system, can we do the environment separately without humans and do humans separately without the environment? We already looked at complexity of our systems. We looked at terrorism, financial crises, and climate change impacts, and so on. Are they to be understood as a whole, or can you understand them in parts? This is a deeper question. There are at least two reasons for this. The first may be deducted from the famous statement that the whole is more than the sum of its parts, indicating that there may be observed regularities in the whole that cannot be obtained by aggregating the regularities of each part. The second is related to the assumption of ceteris paribus, that is, all things that are not explicitly studied stay the same over time. So there is an assumption that you hold something constant while looking at something else. If you are a mathematician, you know when you do partial derivatives, you are holding something constant like time or space and taking derivative in one of them. This assumption does not hold if relations between parts are nonlinear and precludes attempts to hold selected parts constant. However, the vastness and sheer complexity of our universe make it impossible to research anything without reducing it to some extent. So complexity is necessarily simplified to understand the systems at a certain level. According to this view, because just as an example, if you think human and environment can be only understood together, and then you say the environment depends on the sun and the energy coming from the sun, that's one thing. But if you say then sun is part of the universe, then you begin to go into la la land. According to this view, the issue is not whether reductionism or holism is the best approach, but instead how much complexity is allowed to be involved in approaches to particular phenomenon or problems. The guiding principles for finding a satisfactory approach regarding complexity are found in the law of requisite variety and Occam's razor. So let's read it here. The former stating that a model of reality can only model something in reality if it has sufficient complexity to represent it, while the latter, Occam's razor, asserts that this complexity should be kept to a minimum and limited to only what is relevant for each particular phenomenon or problem. So Occam's razor is often used to say things are as simple as they appear, and stated in various ways, but here is a formal definition that we just read. The decisive feature in relation to how this phenomenon or problem may be approached is thus its complexity itself, which as a prop here, how much complexity do you allow in this problem of whatever is being looked at here. Let's say this is Earth and we are trying to study it, and we are basically trying to understand human environment system, as we said. And as I said, we can take energy coming from outside as an input and just deal with what happens to the energy within the system in terms of what's coming and what's going out. But where do you draw the boundaries of our system? Although complexity is a contested concept with a wide variety of definitions and uses, it is in this context commonly related to the number of involved parts, the number, significance, and or non-linearity of relations between parts, and or heterogeneity in space and time. Complicated sentence, but let's not bother with it. However, if any theory or model of reality is a social construction and influenced by both descriptive and prescriptive aspects, then the complexity of any phenomenon or problem must also be related to factors associated with the observer. Ashby's analogy of the brain demonstrates this with amusing clarity and simplicity. Here is how it states: to the neurophysiologist, the brain, as a feltwork of fibers and a soup of enzymes, is certainly complex. To a butcher, the brain is simple, for he has to distinguish it from only about 30 other meats. So it depends on whether you're a neurophysiologist looking at these minute neuronal connections and their functions, as opposed to a butcher. That's why when we say somebody's made a mess of something, we can say it was butchered, or the person butchered it, right? So that's where we will leave this maybe. Well, let's read this rest of it. What is included and what is excluded when addressing a phenomenon or problem are vital considerations, which are referred to as boundary judgments, or to underline their inherently subjective nature. Boundary judgments, descriptive statements about what we know about the phenomenon or problem, and prescriptive statements about our purpose, objectives, etc. of addressing them, are all connected to each other in such a way that changing one automatically causes changes in the others. This is but just in terms of reading is sounding a little too complicated, but as we go forward and apply it to examples in the context of sustainable development, it will become clearer. It is thus crucial to scrutinize systematically what is included and excluded when addressing any phenomenon or problem, as well as what descriptive and prescriptive statements on which those boundary judgments are based. This is especially so when there are multiple actors in the process who may agree on neither. This systematic scrutiny of boundary judgments is called boundary critique and must be practiced carefully when managing risk and resilience for sustainable development. So this is quite a different approach compared to what we will read in Sustaining the Commons, based on Elinor Ostrom's work, whose name will get mentioned here in some context. But essentially there you are just looking at an action arena like an irrigation system, and the action situation where multiple players are trying to use water, and the rules and regulations of what you have to be responsible for when you're part of this system, and what happens if you break the rule, and what are the general design principles for shared resources that come out of this, based mostly on decades of practical field experience and observations by Elinor Ostrom and her colleagues. So this is being stated in a slightly different way. So we'll continue with this, and we'll post that course as well to see what are the differences. Okay. Okay, so we'll come back and look at development, sustainability, and risk in terms of using these philosophical assumptions made, so it'll become clearer that in addition to those complicated words, their use is simpler in trying to do what we are doing in terms of considering the natural environmental system in sustainability, risk, and sustainable development. Okay.